Okay, today we will be learning about parabola at the vertex 0, 0. So if, for example, here is a parabola that is opening upward. Now take note, we have important characteristics of parabola. A parabola has a focus and directrix. Now the focus is located where the graph opens. Since the graph opens upward, so the focus is here, for example. And if we are going to assign focus as F, okay, then the ordered pair for focus, if this is C, then the ordered pair is 0, C, okay? If this is C part of the y-axis. So this is point 0, C. And the directrix is the same distance from the vertex to the focus. So of course the directrix will be here. Directrix is a line. Okay? And this line is y is equal to negative C. So since from focus to vertex is the same distance from vertex to directrix, then since this is C, this one is negative C, right? I hope you are following. Y is equal to negative C. Now, according to what we have learned last time, if we are going to assign a point on the parabola and we are going to connect it to the focus, okay, and we'll make a line vertically going to the directrix, okay, these two lines here must be equal. Now what is the ordered pair for this point here? What is the ordered pair? We don't know what is this, right? So we'll assign this as x, y. And how about this point here? We need the ordered pair for this point. Okay? This is at line y is equal to negative C. So therefore, we have the y as negative C. How about x? X is just x, right? X, comma, negative C is the ordered pair here. Now let us try to solve since we assume that this is equal. If this is point P and for example this is point B. So let us assume that the distance from FP is equal to the distance from PB. Okay? Since these two segments are equal based on the definition of a parabola. Now, FP must be equal to PB. Now, then, we're going to solve for its distance, right? What is the formula for distance? X sub 2 minus x1 squared plus y sub 2 minus y1 squared. Same thing here. x2 minus x1 squared plus y2 minus y1 squared. Now let us try to substitute. Since this is xy and this is point 0C. Okay? So, if this is x sub 2, this one is x sub 1. If this is y sub 2, C is y sub 1. So, we'll try to substitute. X sub 2 is x minus x sub 1 is 0. Okay? Then squared plus y sub 2 is y minus y sub 1 is c. So that is c squared. I hope you are following. Next, the other side. If this is x sub 2 and y sub 2, this must be x1 and y sub 1. Now, x sub 2 is x. Okay? Minus x sub 1 is x. Minus x squared is equal to plus, y sub 2 is y, and y sub 1 is negative c. So that will be y minus negative c squared. Let's continue the process. X minus 0 is the same as x squared plus y minus c squared is equal to square root of x minus x is 0. 0 squared is 0. So, we'll continue with y plus c squared. Plus because negative times negative is positive. Now, let's continue the process. Okay. Extracting the square root. So, to remove this radical symbol here, let us square both sides. And what is left is x squared will be cancelled, right? So x squared plus y minus c squared is equal to y plus c squared. Now, let us continue the process. X squared plus, what is y minus c squared? If you can remember, a plus b squared is equal to a squared plus 2ab plus b squared. If a minus b squared, that is equal to a squared minus 2ab plus b squared. Since this is minus, we will make use of this. So that becomes, this becomes y squared minus 2cy, okay, plus c squared is equal to y squared, we'll make use of this, plus 2cy plus c squared. Now, if we are going to transpose this part here, we will eliminate the y squared, right? Y squared minus y squared. So this will be eliminated. What else? C squared minus c squared. If we are going to transpose this to the other side, so c squared will be eliminated. Okay? Then what is left is x squared is equal to 2cy. Okay? Then this negative 2cy will be transposed to the other side, will become positive 2cy. So we have now x squared is equal to 4cy. This is our standard formula, okay, for parabola, which is the vertex at 0, 0 and is opening upward. We have x squared is equal to 4c. For parabola in which vertex it is at 0, 0. The graph opens upward, it will be opened downward, to the right and to the left. Take note, the equation is x squared is equal to 4cy as what we have discussed earlier if the graph is opening upward. If opening downward, that is x squared is equal to negative 4cy. And then, if the graph is opening to the right, this becomes the y will be squared this time. Again, if x is squared, it can be opening upward or downward. But if the graph is opening to the right or to the left, the y is squared. Okay? So opening to the right, we have y squared is equal to 4cx. To the left, y squared is equal to negative 4cx. So from this principle, we will come up with the standard formula of a parabola if the vertex is at hk, not on 0, 0, but at hk. So number 1. Okay, so number 1, we have x squared is equal to 4cy if 0, 0. If hk, that becomes x minus h squared is equal to 4, okay, c, then we have y minus k. Okay, 4c, then y minus k. Number 2, if opening downward, we have x minus h squared is equal to 4c, then y minus k. Sorry, negative 4c. Negative 4c. For number 3, if the graph is opening to the right, we have y minus. Take note, the partner for y is k. Y minus k squared is equal to 4cx minus h. Then number 4, we have y minus k squared is equal to negative 4c x minus h. These are the standard formula of a parabola in which the vertex is at hk. So that's it.